developers. Thank you for being here today. I'm Diana Târnăvan. I'll be your host for today in this room, the tech room. And we are starting the presentation with a very passionate guy, Gabriel Ciuloaica. He's coming with a lot of background of experience, more than 25 years in several companies, now working as a software consultant for a very passionate company. And Gabriel will challenge the idea of JVM becoming or not redundant. So let's welcome Gabriel Ciuloaica, please.
Thank you for the introduction. Do you guys know that Java has been nominated being the most popular technology by Stack Overflow for many years, starting with 2011 till 2017? Java as a technology was on third place on their surveys. From 2017 to 2019, it went down on fourth place, and then for next 2 years, it went down on fifth place, where last year went down on sixth place, but still is probably the most popular technology that allows you to do cross-platform development. I'm Gabriel Ciuloaica. I'm a software developer. I'm currently working as a consultant. I'm working for a company called Zyverge that is developing the ZIO stack for Scala. During this presentation, what I'm trying to show different alternatives to do cross-platform development outside the JVM, basically. But I'll start with a short history of Java and JVM. Back in 95, Sun Microsystem has created this term, Aura, or write once, run anywhere, to describe the capabilities of Java of being a programming language designed to run cross-platform. So basically it can run on any machine that is capable of running a JVM, a Java virtual machine. Going through the history, as I mentioned in 95, they started publishing the first two pre-releases, alpha and beta, but the first release was in 96. There were a lot of releases almost every year, and then the cadence of releases has decreased. That is because probably some of you know that Sun Microsystem was bought by Oracle, and then it took a lot of time until Oracle started to do releases. For example, in Java 5 was the first version where the generics has been introduced into the language. On Java 8, the first functional programming concepts has been introduced into the language as lambdas. Java 8 is still used in production in many companies today and is having a long-term support. Then from 2017, we are starting to have like 2 releases every year, one in March, one in September. And currently, there are 2 versions that are having long-term support, Java 11 and Java 17. In March this year, we got the Java version 20, where was the first time when we got virtual threads or green threads on the JVM, but still experimental. In September this year, we're going to have Java 21 that will have a few new features like faster startup time, pattern matching enhancement of switch expressions, record in immutability, seal classes enhancement, improved garbage collection, and virtual threads. Now in Java 21, they will remove the experimental flag for virtual threads, basically. We've seen that Java has evolved a lot as a programming language for over so many years, but still there are some criticisms that are regarding to the language itself. One of them being the checked expressions, or the way that the generics are implemented on the JVM. Lack of unsigned integer types, lack of operator overloading, or too verbose. You have to write a lot of code to implement simple functionality. Sure, there are tools that help you to reduce that verbosity, but still it's considered too verbose. To address this criticism, there were other programming language that has been created to run on the JVM. And the first one that has been created is Groovy. Groovy is a dynamically typed language. It could be used as a scripting language also, but it has the disadvantage that is bringing dynamically type on the JVM, in the sense that people that are used to programming in Java could be surprised by the fact that you can compile properly the code and the runtime you see errors. Then the other language was Scala. Scala has been officially released in 2004, was the first programming language that brings functional programming on the JVM. It also provides you the ability to work on both functional or object-oriented way, or to combine both of them. Scala is the strong statically typed language and a general purpose one. Java was the first language to bring also immutability on the JVM, where the variables in Java by default are immutable. If you want to have something immutable, you have to declare being immutable, or to use var instead of val. Also, we are seeing now that we are getting records on the Java, but Scala had same concept in terms of case classes from beginning. Another programming language is Clojure. And Clojure is a purely functional language, but it has the disadvantage that has this syntax that's far away from everything that the developers of Java are used to, being a Lisp language. And I think the latest important programming language on the JVM is Kotlin, that has been released in 2016. Has been created by a company called JetBrains, and I think all you know JetBrains if you are Java developers, because they are building the, let's say, the most interesting or most evolved IDE. All these languages has contribution or contribute back to the Java language with different functionalities. That's why I'm thinking that right now Java as a programming language is still evolving, but it's not innovating. It's basically in a reactive mode, taking or incorporated language concepts from other languages, but it's still evolving. All these languages give you the ability to do cross-platform development. Let's talk a little bit about the JVM. JVM is the virtual machine that is able to interpret the bytecode that is produced by the compilation of all these languages that are capable to run on the JVM. But over the year, the JVM also improved a lot. But I think they still have two issues. One is the cold start and the memory usage. Now you're going to tell me, if you have a lot of experience on the Java, that probably cold start is not anymore a real issue, because we have GraalVM that help us to compile the bytecode to something close to native and improve all the warm-up performance. But it comes with its own own problems. It requires additional explicit configuration, and not all the libraries could be compiled by GraalVM. For all these reasons, I think Java at this moment is not evolving fast enough to compete with other technologies that are giving you the ability to do cross-platform development. One of the technology that is quite mature right now on the market and is used by a lot of companies in production is Docker. You're going to ask that Docker is not a programming language. It's not a programming language, but it's a platform that gives you the ability to do cross-platform development without being constrained by developing the application in a single language. In the same time, Docker is giving you the ability to move fast from one machine to another, from one data center to another, being very familiar for developers to build something on Docker because you are used with the commands that Docker is using every day, like build, push, pull. It's the same, very similar with Git. But Docker is a set of platform as a service that use OS operating system level virtualization to deliver software packages to containers. Container is the isolated one from the other, so it's contained everything in one container. It's not affecting the environment in where the container is running, right? And Docker has its own benefits. But Docker is not new. It's already 10 years old. And I think that Docker will remain on the market for another 10 years probably. But right now, the technologies are going in a totally different direction. Till now, we had the ability to write in a single language, compile it to bytecode running everywhere where a JVM could run. We have Docker that you are not constrained to a language, but you can move your program anywhere you want. There is another technology now that is called WebAssembly or WASM. I think for front-end developers, WASM is not something new, or WebAssembly is not something new because it starts by being used or replaced the Java on the browsers for some time already. And there are known products like Figma or even AutoCAD that give you the ability to run the entire AutoCAD in the browser thanks to this technology. And it was designed as a portable compilation target, right? I have to compile my program to a specific target, and that target being WASM. It's like for people that done C or C++ development, I want to build this program for Windows. I have an output, a target for Windows. I want to build it for Linux. I have a different target, a different binary, a different build. The same I'm doing with WASM. I'll have a different target that is WASM. But WASM or WebAssembly, the standard, it allows you to run something in a sandbox. Being in a sandbox, you don't have external access to sockets, to files, to anything, right? So it could not be used in that form on the backend, for example. And for that reason, there is a standard right now that is called WebAssembly System Interface, or WASI, that is trying to standardize the way that a runtime provider will give you the ability to interact with something like a socket. There is one quote from the creator of Docker, Solomon Hykes, that is saying if WASM and WASI was available at the time that he created Docker, he'll never create it, basically. One implementation of this WASI interface is called WASIX, that is giving you all the POSIX-like capabilities for an WASM application. Currently, there are different clouds that are providing you ability to run WASM application remotely or locally. To be able to run a WASM application, you need to have a runtime that gives you the capability to interact with something externally. Another quote from Solomon Hicks is about WASM and JVM. And it's basically, he's saying that he has a lot of trust on this new technology. So JVM will evolve and will continue to be used. It's not really redundant. You can continue to use it, but for certain situation or certain use cases, you need to adapt to your needs, right? Probably Docker will be something better. Probably something more native, something close to WASM will work much better for your situation. And I have one more thing to show you before I switch a little bit to code. I have a benchmark here that is comparing a very simple but not trivial application or microservice that is basically taking a JWT token from a request, verify it, extract from the claims an email, check that email against the database, a MySQL database, and then returning the result to a user, to the caller of that initial request. Here I have two implementations, one done with Spring Boot and one done with Rust. You can see the big difference on memory usage between these two implementations. And you can find more benchmarking like this if you follow this link. I'll put it somewhere to be accessible for everyone. And we talk about programming language on the JVM. We talk about Scala. Because I'm a Scala developer, I'm going to show you how easy and how concise it is to create a small microservice in Scala. So this is the entire code. It's fitting in a single slide. This is a simple microservice that is able to reply to a GET request, and instead of giving you just a simple reply, is basically giving you a set of data by providing you the server-sent events implementation. Right? This is just Scala code, simple Scala code. Everything that you see on the slide are no statements, are only expressions. Will be evaluated only when I call the run function. So to go a little bit through this code, on line 18, we're basically building an infinite stream of data by using a scheduler that gives me the ability to emit the current local date time at every second. Then I'm defining an endpoint that is basically exposing my functionality on the SSE path, and the format of the output will be a stream that will contain server-sent event data type. Then I build a route, and to build a route, I need to attach to my endpoint the functionality, the handler of that request. And this is what I'm doing with SSE endpoint implement, where I'm basically passing the stream to that function. I'm not expecting any input, and I'm just replying with the stream. On line 27, I'm basically building the app, attaching the root to an application. Here, if I have more functionalities, I can combine all the roots in a single application, and then I'm deploying the application on a server. On the run function, I'm basically just providing the application and start the server with a default configuration. The server default is basically telling that we run the service with default configuration, and the exit code at the end is that I'm interested only on the exit code. I'm not interested of any other output from this server. And to prove that is working, let me try to see if I can start it. All right, then let me find my mouse back. I'm switching to curl. I'm gonna use curl for this. My server is starting on port 8080. The path is SSC. And if I start it, I'm already starting getting the responses. You see that the content type is text event stream and the transfer encoding is chunk. Now I'm gonna get an infinite stream of current datetime space of 1 second. Curl is able to understand the server-sent event protocol. Okay. This is one piece of code that I wanted you to share. And the second one, it's much, much simpler and less code than previously. Here, do you recognize the programming language? It's Rust. Rust, it's a programming language that compiles to native code. It's not running on the JVM, right? So here, I'm just building a catch-all handler for a request. I'm basically defining a function, handle demo Rust was, that is taking a request and returning a result, a response. A result is a data type that could succeed or fail. In case of succeeding, I'm taking a response out. In case of failure, I'll get an error. On the next line, I'm just printing the headers out that I'm getting through the request, and then I'm just responding with 200 OK and with some content to any request, right? This is the code enough to build a very simple microservice. It's very concise. Rust is using Cargo, that is quite similar with Maven or Gradle or SBT on the Scala side to build this project. And the equivalent of POM XML is the cargo toml, where I'm basically describing my dependencies. Here I'm using another component that is called Spin, that is a way to develop WASM microservices that could be run on Pheromone Cloud. It's a new cloud that is capable of running and giving you the abilities to run WASM application. It's giving you access to socket to be able to expose functionality over HTTP. It's giving you access to Redis, for example, or other databases that you might need. To compile this code to WASM, it's very simple. Spin is doing that for me, but I can show you exactly what it's doing. In order to build this code to be deployed as an WASM, I just need to specify the target, being WASM42 WASI, and release to have a release built in, without debug information in it. Let me try to run it. Now I'm not touching the Pheromone Cloud. Everything is run locally. But I started my application, and then if I go back to my terminal. On port 3000, I started this server. As I mentioned, it's just a catch-all server, right? It's responding right away. I can use any path I want to respond or same thing. You see how fast it is to start it. Okay, thank you. This is my presentation. I'll switch back to slides and I'm open for questions.
Now is the time for you to interact with Gabriel. Any questions in the room?
Test. Any question? No? Yeah, I wanted to ask you something, Gabi, but no. Oh, should be fine. Let's give him a round of applause.
Yes, well, thank you, Gabriel.
Thank you.